logic and tautology. It works because it works. It's self-organization because it's built in, and therefore it's self-organized. So we have seen molecular chemistry is the start of all the chemistry we are doing, and this then is the art and science of handling covalent bonds, breaking bonds between atoms and making them in a more and more complex way, inventing new reactions, which is one of the most important things in chemistry. Reactions, some of them exist in nature, many do not exist in nature. I could just cite one, metathesis, for which a prize has been given some years ago, does not exist in nature, at least, but doesn't know examples in nature of metathesis. Palladium CC coupling, carbon-carbon coupling with palladium catalyst doesn't exist in nature. Chemists have invented it. And this is something to realize, that nature has not tried everything, because there was no occasion to try it. But chemists can do it. And as you know from this morning, beyond molecular chemistry lies supramolecular chemistry, where we want to master the non-covalent bonds the way organic molecular chemists have mastered the covalent bond. And this is sort of an interesting, you might ask, why has it taken so long to start only in 1965, 70? I think my main reason is because before that it was very difficult to analyze what you had. Non-covalent interactions are rather weak, so supramolecular entities are not very strong in terms of their constitution, and so analyzing them, deciding what it is difficult. And you get aggregates, so you need very well developed physical methods. And that is one very important thing chemists owe to the physicists who have discovered the methods, to the engineers who have developed them, to make mass spectrometry, to make NMR spectrometry, all these techniques which allow you to look at what you have in your flask. This was not possible earlier. And so I told you already that the three main features at the beginning of supramolecular chemistry was to understand how molecules recognize each other, how they react with each other, and how they can carry each other through a membrane. It can be a natural one, or it can be a cell membrane. And then beyond these first features of understanding molecular recognition processes, information processes in chemistry, supramolecular chemistry, comes the fact that you can then try to use this, what you have learned, to set up molecular recognition directed cell organization. And you have seen part of that slide already this morning. You want to have a system which spontaneously, but in a controlled way, not just something you mix and it happens. You want something, you mix it and you know what should come out. If it comes out the way you think, then you probably understand something. If it comes out differently, that means you also get new knowledge because something else has happened and you haven't understood it yet, and then you add it to new knowledge. So in fact, this is an interesting thing in this type of chemistry. Whatever you get out, you get something positive. If you get what you want, okay, you think you understand. If you get something you did not predict, then you have made a discovery because there's some new factor which you didn't know about. Now, one important thing is that this question, of course, was too complicated to raise this morning. Self-organization can be equilibrium self-organization, which also sometimes are called passive self-organization, or out of equilibrium self-organization, which are called also active. Now, the people of the school of Prigogine, for instance, of nonlinear thermodynamics, for them, self-organization is a nonlinear process which is necessarily out of equilibrium. And they call self-assembly what is just getting things together. I don't like that too much because self-assembly is just putting things together. But this getting together may well be organized, but it may well be in equilibrium. So I prefer to distinguish between equilibrium self-organization, or passive, and out of equilibrium self-organization, which is active self-organization, like in humans, like life is. Life is self-organization out of equilibrium. We know that because we die. We are out of, things stop, we are out of equilibrium, so disappear. But disappearing is the condition of evolution. If you don't disappear, you don't evolve. Unfortunately, so. So, I've already mentioned that, but now we go more into details. That one part of supramolecular self-organization